a review for the end of Module 5. We're going to start with question 1. A fish tank in the shape of a right rectangular prism. Right there tells me I'm going to start with some volume because that's usually what those are for. It is 12 feet deep. The top of the fish tank has an area of 230 square feet. What's the volume? As soon as I see volume, I know that I have to write the formula of volume equals length times width times height. So now I'm going to plug things in, and I notice this is deep. Anything with depth or how deep something is, that is the height. I don't see a length and a width, but I see the word area. And I see right here that I have length times width. And when you do length times width, the formula for it is area. So instead of trying to figure out the length and the width, I just take my 230 and I plug it in for the length times the width. And now I have to do length times width times height, which is 230 times 12. And I can do the math over on the side. And when I do the math, I come out with 2,760. And I know I'm working in feet from up here. And when I do volume, it is always feet cubed, so I put a little 3 up there. Or it would be cubic feet is another word that I could write. Go to the next one. We have this toy box. It's a right rectangular prism, and they want to know the volume. So once again, I write volume equals length times width times height. And I plug the numbers in. My length is right here. So I see that that's 8. And my width is over here. So I plug in my 4. And my height is how tall I am, which is 5. And when I do 8 times 4 times 5, I come out to 160. I see I'm working in centimeters. So I write centimeters cubed. Next, we have question 3, where we have Eric, and he is filling a box with layers of unicubes. It talks about the volume and that there's 125 cubic units. What can you tell Eric about the box and its unicubes that are true? So when we look at this box and it has 125 units, we know that the box is filled. It's not covered, it's filled when we talk about volume. And we know with exactly 125 cubes. So what's important to point out is when we have volume, we know things are filled, and we know this is how many cubes there are, because they have unit cubes, and unit cubes means that they're each 1 unit. So next, we go on to question 4, and we have Erin. And Erin is filling a box with wooden blocks. They're each 1 unit cube, which means that they're worth 1. She fills the bottom layer with 15 wooden blocks, and then she stacks 2 more wooden blocks on top of the bottom layer. This is our partially filled box, but we want to know the total volume of the box. And the total volume of the box, not just the partially filled, is we want our length times width times height. And I can do this 2 ways. One way is that I can say right here my length is 5. I can see that my width is 3. And I can see that my height right here is another 3. And 5 times 3 times 3 is 45. Or they told me before, if I go back up top, that the bottom layer has 15. So that would be the base area. So if I did length times width times height again, and I just filled in my height was 3. And I know that there were 15 down here. Length times width is 15, and if I do 15 times 3, I also will get 45. Either way that would work, but I also need to make sure that I have cubic units. So we could do units to the third. And over here we can write units to the third because they're cubic units. Next, we have question 5. Talking about prism A is what's here. So here's prism A. The height of prism B is 3 times the height of prism A. So let's go back and look at prism A. We have a length right here, and the length is 5, and the width is 3, and the height is 2. And now it's asking for the volume of prism B. But over here, this was A. So now we're going to check for B, and we have B right here. So the length's not any different. They didn't tell us. The width right here, they didn't tell us anything was different either. But the height is 3 times that. So I have to say that I'm doing 2 times 3. And 3 times that, 2 times 3 would be 6. And so now we're going to go through and we're going to find the volume of B, which is everything that's in the green. So we have our volume equals length times width times height. And when we do the length, we have 5 times 3 times 6. And when I do 5 times 3 times 6, I end up with 90. And we're talking about inches. So we do IN, and we have it to the third power. Next, there is a question missing here. So what the question is going to ask you, it lists the number of layers of centimeter cubes, along with the number of in each layer for 4 rectangular prisms. And what the question should have asked, I'm going to type it out for you so that you can see it. What rectangular prism has the greatest volume? That should be the question. That's missing, which is why you couldn't solve it. So I'm going to go through, and if I know my number of layers, and if I know my number of cubes in each layer, I can just multiply them together. So I'm going to go through all these and multiply these together, and I end up, I get 24, I get 25, I get 30, and then I get 28. And when I look through these, I see that this one has the greatest volume, so my answer would be prism T. Question 7, Andrew completely filled the box shown below. So we're looking at that box, and we know that everything that we're going to work with is 1 cubic unit. He counted the number of cubes he used to fill the box. What measurement is that? Well, when we want to fill the box, as soon as we fill it, if we're filling it, we know that we are finding volume. That's what he's doing. Next is figure below is made of unit cubes. Unit, once again, tells us that there's 1. So how many unit cubes need to be added so that the volume will be 12? Well, we want 12, and so we're going to count up what's there. We have 1, 2, 3, 4, 5, 6, 7, 8. So we take 12, we take out the 8, and we would need 4 more cubes. Question 9, once again, we have a right rectangular prism, and the volume is determined by using these cubes, or 1 inch by 1 inch by 1 inch. And then we want to know which statement would describe how to determine the volume. So I can explain to somebody that in order to get the volume of this, I first would need to find the area, which is 4 times 3. And if you notice right here, we have the length times the width. And then after we do that, we want to make sure that we multiply the number of layers. And if we take 4 times 3, which we just said before, and then we multiply 2, then that's how we would find the volume. Next, we want to know what the volume of this cube is right here. So it's a formula that we know very well, which is volume equals length times width times height. And we see that it's 1 times 1 times 1, and 1 times 1 times 1 is 1. It's 1 unit cubed. Here we have a multiple choice. Which phrase best describes a figure with the dimensions of 2 units by 2 units by 4 units and a volume of 16? Well, volume tells me that we are filling. So right away when I look, I see filled, filled, covered, covered. Covered means area, and we are trying to find volume. So since these two are area, I know right away that I can eliminate them. So now I'm going to look, and we want to say a solid figure that can be filled with 16 cubes, or a solid figure that's filled with 1 cube. Well, the cubes are usually 1 unit. So I want to get rid of the fact that there's only 1 cube, and I want to say that I'm putting 16 cubes in there. Next is question 12. And on question 12, we're another right rectangular prism. The length is 8, the width is 3, the height is 5, and we want the volume, so I'm going to write my formula again. Volume equals length times width times height. And our length is 8, our width is 3, and our height is 5. And when I multiply them together, I get 120, and it's feet cubed. Next, another multiple choice. Which phrase describes the volume of a three-dimensional figure? Well, when we're working with three-dimensional and volume, we know we need cubic. And we know that when we have square, it equals the area. So we know right away we can get rid of square and square. So we see these here now, and we see we have cubic and cubic, so we have to keep going farther. This says to fill, and this one says to cover. And here, when we're doing volume, we fill, and area we cover. So our answer for this one, we would eliminate this, and our answer would be choice B. Next question. We want to know the volume, but we have to look on the next page for what the shape actually is. We have our rectangular prism. We have volume equaling length times width times height. So we look at the length, and we count 1, 2, 3, 4, 5. And we look at the width, which goes this way. We have 1, 2, 3. And then we look at the height, which is 1, 2, 3. And when we multiply those together, we get 45. And since we're working with centimeters, it's centimeters cubed. Next question. Which of these diagrams represents a volume? So we want 3 dimensions. Volume tells me 3 dimensions. And then we also want to look at the fact that it's cubed. So we want a cube, not a square. And that's important too, that we want a cube for volume. We don't want a square. So when I go down here, that is a square, that's a square. These two are cubes. So now we have to figure it out. We want the volume of 1 cubic unit. The volume of 1 cubic unit would be this, because it would be 1 times 1 times 1, which equals 1, as opposed to this one, which would be 2 times 2 times 2, which would be 8. So my answer would be D. Now we have Caitlin using cubes, and we have to read this question carefully. The first thing I'm going to do though is I see there's a right rectangular prism. So right away I start counting and I find our volume. And when I check this all out, I count this, it's 1, 2, 3, 4, 5, 6, 7, 8 is my length. My width is 2, and my height is 4. And when I multiply all these out, I get 64, and that's where some of you would try to stop. You have to read the rest of the question though. She makes a smaller prism using 1/4 of. Of tells me to multiply of the number of cubes. So we're going to find 1/4 of 64. And when we find 1/4 of 64, we can do it two ways. I can say 64 divided by 4 times 1, or I can multiply straight across. So I could end up, if I multiply straight across, with this. And when I solve it, I get 16. And we are working in cubic inches, so it would be inches cubed. Next, we have this locker, and we have all the numbers on there, and it says to find the volume. So we're going to do our usual volume equals length times width times height, and our length is 12, our width is 8, and our height is 30. This number in here is nothing, it's just the locker number. And 12 times 8 times 30, when I do the math out, I end up with 2,880 inches cubed. Question 18. The dimensions of Mrs. Chen's living room are these. And the dimensions of her family room are these. What's the total of the two rooms? Well, this goes back to just like when we were trying to find when we had prisms stacked on top of each other. So volume equals length times width times height. So right here, we have 10 times 18 times 8. And when we do that, we get 1,440. And then when we do the next one right here, it was 14 times 20 times 8. And when we do that, we end up with 2,240. And now we have to go and add these two volumes of the two rooms together. And when we add them together, we get 3,680 cubic feet. I'm going to just rewrite that so there's not that big space in between. There you go. And that would be the answer. The next one takes a whole bunch of steps, so we have to read very carefully. The diagram below shows a set of 3 different size containers. This is the largest container, so that's A. So we're going to start off, we know what A is, and we're going to put it here because we want to know everything combined. So A was 12 3/4. So now we're going to work on B. And if I look up here, it says 2/3 of the amount of container A. So we're going to find 2/3 of 12 3/4. And so we're going to do some of the math. And when we multiply a mixed number, we've learned that we have to turn this mixed number into an improper fraction. So we do 4 times 12 is 48. 48 plus 3 is 51. And so we have 51/4. Now we have to do 2/3 times 51/4. And when we multiply that out, we get 102/12. And then after we get 102/12, we have to turn it into a mixed number. So 102 divided by 12 is how we solve that. And when we do that, we get 8 and 6/12, which I can simplify to 8 and 1/2. So now we're going to try to find C. So we go back up here and we see that C is 2/3 the amount of B. So we go back here to C and we have 2/3 of 8 1/2. But we saw back here it was already turned into a mixed improper fraction for us. So we can just use that improper fraction and not have to do the conversions again. So we're going to make this 102/12. And when we multiply that out, we get 204/36. And we don't want to leave that as an improper fraction. We have to change it into a mixed number. And when we do 24 divided by 36, we end up with 5 and 24/36. And then 5 and 24/36, we can simplify. We can divide 24 and 36 both by 12. And we end up with 5 and 2/3. So now we know what A, B, and C all are. The question says, what's the total amount? So what we need to do is add A and B and C together. So we're going to do that over here on the side. So I'm going to take 12 and 3/4, and I'm going to add 8 1/2, and I'm going to add 5 and 2/3. So when I go to do that, I see they all have different denominators, and since they have different denominators, I need to change them to the same denominator. So I'm going to bring over all my whole numbers first. And now I'm going to see what common denominator can I make with 4, 2, and 3. I can make 12. So I ask myself, what did I do to each of these to get to 12? Because that's what I have to do to the numerators. And if I look at it, I have to do 4 times 3, which means it's 3 times 3, which is 9. And 2 times 6, and 1 times 6, we'd end up with 6. And 3 times 4, so 2 times 4 is 8. And when I add this all up together, I get 25 and 23/12. Well, I can't leave this as an improper fraction like that, so I have to change it again. And when I change this, I see 12 can go into 23 one more time, so that gives me 26. There's 11 left over out of 12. So I end up with 26 and 11/12. Next, we have Mrs. Smith, and she needs to she needs to ship 8 boxes of cookies in a packing carton. Each box is 8 long, 5 wide, 3 high. What's the volume of each box? Not all of them together, just each box. So volume equals length times width times height, and each box is 8 times 5 times 3. And when I solve that out, I end up with 120. That's the first part of that question. Now I go down here, and Mrs. Smith wants to ship all 8 boxes in one carton. So first I need to see if she had 120 for 1, and she ships 8, then I need 960. But I have to see what the volumes are on each of these to see which one I can ship with. So for each one, I'm trying to figure it out. So this is 11 times 10 times 8. This one is 16 times 10 times 5. And this one is 17 times 11 times 7. And when I solve all of these out, I'm going to put the numbers over here so we can see them. This one becomes 880. This one becomes 800. And this one becomes, I gotta do some math on this one. 17 times 11 first. And then we take that 187 and we're going to multiply it by 7. and we have 1,309. And when we have that, we see that we need 960. It won't fit in some of these. It won't fit in this one or this one, so the answer has to be C. That's the packing carton that they will use. Next, prism X is shown, so we're going to look at prism X and figure out its volume equals length times width times height. And we see in here that the length right here is 5, the width is 2, the height is 3. And now we're going to keep reading. The volume of prism Y is 60 cubic centimeters greater than X. So if we figure out X still, we end up with 30. But now it's telling us that it's 60 greater. So if we have 30 and we add our 60, we end up with a volume of 90 cubic centimeters. And when we have a volume of 90 cubic centimeters, it's asking me what could the length, the width, and the height be? So there's a lot of answers. So my answer to make 90, I think I can take 15 and multiply it by 2, which is 30, and 30 by 3 is 90. That's one that works. I can have 30 to start and multiply it by 3 and then by 1, and that would also give me 90. So you have to see which ones work to make 90, and that's the review.